Begin with type in JAVA Java software free download. Click on the very first option provided and download Java. Secondly, Circuit Mod Simulator free download. Click on it and download. Click on the icon provided on the desktop, Circuit Mod. It will take you over a blank screen. Let's see the various options provided here. File, New, Open, Save, Save As, Edit, Cut, Copy, Scope, Options, Show Voltage, Current, Power. On the screen over here, the option of white background, circuits, start and stop button to carry out the simulation, to adjust the simulation speed, scroll button, to adjust the speed of the current, one more scroll button. A right click on the mouse will provide you the various options of adding the different components etc. on the screen. Add wire, resistor, capacitor, ground, passive components, input outputs, active components, logic gates, chips, display devices, CD series, others, and the most important again, a select and a drag option. This option is available for us with a right click. To begin with, let's start with logic gates. Looking towards the symbols, let's study the various logic gates in Circuit Mod. As a good practice, initially save the file, save as with any name. Right click, logic gates, inverter, scroll it towards the right. We need one logic input and one logic output. Right click, input outputs, add logic input, add logic output. Let's select them one at a time. Add logic input. Drag it towards the left. The letter L should appear at the end. Right click, input outputs, add logic output, drag towards the right. Let's start the simulation. Similarly, right click, another logic gate, say AND gate. If you drag it in the downward direction, it will look as like. You can drag it in the other direction as like. I don't need them, so what I can do is click on it and press the delete button on the keyboard, or else right click, select and drag, select with the mouse and press the delete option. We have the AND gate. We need two logic inputs and one logic output. Right click, input outputs, add logic input. We need to drag twice. Once, and this is the second time. Now a slight change in the output section. Right click, instead of selecting from input outputs, the Add Logic Output option, we will switch over to the Display Devices and add a LED. See now, if we drag the LED, we can see the two red dots, which means there is no connection. The connection is wrong. Click on the option, press the delete button, right click, Display Devices, add LED, right click, add a ground to complete the circuit. Now start the simulation. The output is high when both the inputs are high, else low. Let's have the third logic gate. Right click, logic gate, OR gate, drag it on the screen. For output this time, we will have from Display Devices a lamp beta, the lamp that is used in table lamps. Add ground. We need to add two logic inputs, input outputs. Add logic input, drag it twice, and now it's already on. Let's start the simulation. Similarly, you have the derived gates and verify the truth tables of all the logic gates. Now using logic gates, let's try to build a small circuit of half adder. Looking towards the logic circuit diagram of half adder, let's have an XOR gate, right click, drag. We need a AND gate, right click, select the option of AND gate and drag. Let's have the wires, add wire, first wire, similarly drag the second wire. We need to connect the AND gate to the XOR gate. Now there are no points over here, so let's click and delete, add a wire. We want to connect over here, so add a small wire. Now there are two connecting points and then connect the wires. In the similar way, delete, then extend these two wires for the main inputs AB. Connect the logic inputs and the logic outputs. Right click, input outputs, add logic inputs, drag twice in the reverse direction, of course. Right click, input outputs, add logic outputs. Instead of adding logic outputs, you can add LEDs. This is how the simulation of half adder takes place. As we know, half adders are used in calculators, and then open full adder, and this is how the full adder circuit is simulated. As we know, application of full adders are in digital processors. As per the diagram, we need 4 OR gates, right click, logic gates, OR gate. Drag it 4 times in the downward direction. Second, third, fourth. Note that the first OR gate, the one which is highlighted, is 5 input. So click on it, right click, edit, 5, apply, OK. Edit, 4, apply, OK. Right click, edit, 4 inputs, apply, OK. Then we need a 5-volt supply. Right click, input outputs, add voltage source, 1 terminal. Click in the upward direction. This is how we get the plus 5 volt supply with 1 terminal. If we take the arrow on this plus 5 volt, we can see its specification over here. This is how it goes. Now we need 10 switches. Right click, passive components, add switch S. 1, 2, 3, 4. Just drag them towards the right. One, two, three, 4, 5, 6, 7, 8, 9 and 10. When we want to connect them through wires, right click, add wires, first, second, third and so on, and then we will right click, select and drag, select the plus 5 volt supply, bring it over here and then add wires, and in this way we complete our circuit. Once our circuit is done, then let's go for simulation. Click on the switches to observe the output. Multiplexer. Let's give its name. Right click, display devices, add text, drag the mouse as many times as you want. Right click, edit, 4:1 multiplexer. Font size, apply, OK. Highlight, right click, edit, A. Font size 16. Apply. OK. Select. Right click. Edit. B. Font size 16. Apply. OK. Right click. Select and drag. Select. Drag. Select. Drag. The select line inputs AB. Our circuit is ready for simulation. Let's go for it. 0 0 0 1 1 0 1 1. Similarly, design the circuit for 1:4 demultiplexer and go for its simulation. 0 0 0 1 1 0 1 1. Binary to gray converter. Looking towards the truth table, one can simulate the circuit. Similarly, we can simulate gray to binary converters. Applications of gray code as gray code counters and arithmetic, error correction, Boolean circuit minimization, position encoders, etc. BCD to 7 segment display. Design the circuit. Let's start for the simulation. 0 0 0 0, a display 0 1 2 3 4 5 6 7 8 9. 4-bit parity generator and checker. The circuit includes two parts. First, even parity generator, even parity checker. Even parity output 0, odd parity output 1. Parity generator and checker is used to detect errors in transmitted data caused by noise or some other disturbances. Yes, dear. In only 1 hour, learn entire semester theory syllabus by clicking on the link given below in description. Leave a thumbs up and press the subscribe button.